Hello, welcome to my channel. In this video, we are going to be solving problem under capacitor. So the problem we are going to be solving is given in the form of a diagram. So we're asked to find the capacitance of this system, the equivalent capacitance of this system. To solve this problem, it's important for us to know the expression for capacitance, and it's given us, first of all, we have our D, which this part is given as D over 2. The other part is also given as D over 2. So the capacitance of a capacitor when there is no dielectric is given as C naught epsilon naught times area all over D, where this part is the relative permittivity. The capacitance, the area, the distance, D. This D is this part, the distance between the plates. Area is the area of the plates. Now, when there is a dielectric inserted inside the capacitor, then the capacitance is now equal to C equal to dielectric constant E naught A all over D. So for this system, we can consider the first one, the capacitance for the first dielectric constant to be C1 equal to K1 E naught area all over D all over 2, because the distance here is D all over 2. While the length still remains, so it maintains area A. So the capacitance of this second dielectric as a result of the second dielectric is given as C2 equal to K2 E naught, the same area, D over 2. Now, to solve this problem, we can visualize this system as though these two dielectric are connected in series. So we have it in this form. They are connected in series. That's the way we can visualize it. A current goes through, passes through. So it's as though they are connected in series. Now the capacitance of two capacitors connected in series is given as 1 over C. The equivalent capacitance is given as this. Now if we make C the survey formula, by simplifying this one first, we have 1 over C equal to C2 plus C1 all over this. Then make C the survey formula, we have C equal to C1, C2 all over this expression. Now, at this point, we can substitute the value of C1 and C2 as this and this into this expression, and we have this expression. At this point, we can simplify the top and the bottom to have this expression. We can see that this times this will give us K1, K2, E naught and E naught will give us E naught squared, A squared, D over 2 squared. This one, we can simplify this one to be this one by adding these two, since the denominators are the same. At this point, we can split into this one times this all over this to give us this expression. So at this point, we can cancel out certain parameters that are equal. This can take care of the squared. We can even factorize EA out, and the EA will cancel one of this and this, so that we have this expression, right? So our final expression becomes C equal to 2 E naught A all over D, K1, K2, K1 plus K2. That's it. So we can also look at the second part, which is given in this form. And if you look at this part properly, we're asked to also find the equivalent capacitance. So to solve the equivalent, to find out the equivalent capacitance of this system, we can also imagine that this one is given as C all over K1 E naught, this time around A all over 2. The length is half. And if you notice, if the length is half, the area will be the length times the breadth. So, and the area will not be half, but the D is the same. So likewise, the capacitance for the second dielectric is given as this expression. Now we can also visualize this system as though these two dielectrics or these two capacitors are connected in series, in parallel. So we have this expression, right? And the equivalent capacitance of two capacitors connected in parallel is given as C equal to C1 plus C2. Hence, if we substitute this C1 and C2 into this expression, we have this expression. We can factorize common factors and see that our C, equivalent capacitance, is equal to this expression, all over 2. Right? So if you compare this with that of the previous slide, which is the former one that we solved, you discover that the capacitance of this is higher than that of the previous one that we solved. I hope this helps. Please like, share, and follow for more. Thank you.